Yeah, let's have a seat. Good afternoon, just afternoon, ladies and gentlemen. Uh, it's my pleasure to chair this session on unleashing the power of nature, exploring natural fibers and biosourced materials in the composites industry. In this session, we will explore both bio-based fibers and bio-based resins. And the reason is that if we want to have composites which have as low as possible ecological impact, then we should try, one of the options is to try to have both the fibers and the matrices to have them bio-based. On the fiber side, we have quite well-established processes to extract the fibers, flax and hemp and other fibers from the plants. And what we saw in the past decades is that these fiber extractors, flax and hemp fiber extractors and other fibers have developed technologies to produce preforms which are specifically usable for the composites industry. And at the same time, we see, since about 10 years, a little bit more, the coming up of bio-based resins. And also these are now coming into an era where they are being used as a matrix in the composite applications. And finally, we see a lot of companies now adopting these technologies and producing products, bio-based, fully bio-based products, or partially bio-based products with either bio-based fibers or bio-based resins. Why do we have these bio-based materials? Not only to reduce the ecological impact, but also because they have sometimes additional interesting properties. And just to mention two, because of the fibrillar microstructure of fibers, of bio-based fibers, they have excellent vibration damping properties. And if you are using a transparent matrix, you can make visible the nice natural look of these fibers and make your product immediately looking kind of natural. In this session this morning, or this just afternoon, we have 6 distinguished presenters who present each of them, or represent each of them, a certain aspect of this bio-based composites industry. I would like to first introduce to you Christian Fischer. Christian is CEO of B-Comp. It's a company which he also co-founded with some friends, and it's one of the leading suppliers in lightweight solutions based on mainly flex fibers, and they recently, and you can visit them at their booth, made a breakthrough in having a first product in a mass-produced car. Then we have Mr. Corey Tyree from Trillium. Trillium, he is co-founder also and CEO of this company. And this is an interesting innovation because they make, as he told me a minute ago, the precursor for the precursors of carbon fibers. You know, the precursors of carbon fibers are polyacrylonitrile. They make a bio-based acrylonitrile, which can then be used for making polyacrylonitrile and for making carbon fibers, and hence they have the potential of drastically reducing the life cycle impact of carbon fibers. Next to me is Christoph Geyer from Sartex. Sartex is a well-known company in the composites world, making all kinds of preforms out of carbon and glass fibers. And they, a couple of years ago, they made a step towards also using natural fibers, mainly flex fibers, to make non-crimp fabrics, for instance, which are then used in composite applications. Next to me is Martin Jensen. Martin Jensen is also founder, and we have a lot of founding people here, founder and CTO of the company Pond. And the company Pond in Denmark is producing bio-based thermoplastic resins, which can then be used as matrix for composites. Next we have Marcus Kramer. Marcus Kramer also founded his own company, Eve Reverse, and they are focusing on making the conversion from bio-based fibers to fibers which can then be used as a reinforcement for composites to make that conversion more efficient, more effective, and he will certainly explain us later on how he is doing that. And finally, we have Xavier Payou from Materiact. Materiact is a division of Forvia, and Forvia, you might certainly know it, was a conglomerate when Faurecia and Hella were joining forces. Forvia is one of the major producers of products or parts for the automotive industry, and they are now also going into the development of compounds for bio-based compounds, bio-based fibers, recycled matrices for composites. So, my first question to three of our distinguished engineers here is, can you make a 1-minute statement on what is, in your feeling, the state of the art of bio-based composites in the world now? And I would like to ask this to our representative from Trillium, Mr. Tyree, to Christian Fischer, and also to Mr. Geyer from Sartex. So please.
Okay, so our perspective on demand. As we pointed out, we are focused on making the precursor to the precursor. So my perspective will also focus on that. I know it sounds very niche, but this is one of the 20 biggest chemical markets by volume in the world. So let me tell you what's going on there. I can give a clear answer. There is growing demand for that sustainable precursor. What evidence can I offer there? I'll give you two things. One, there is sustainable precursor being made today, and it's being sold. Why does that matter? 5 years ago, the answer to this question would have been 0 being made, 0 being sold. Is it then being sold into the carbon fiber composites industry? We've got multiple announcements in the last 12 months that say some of that sustainable precursor is being sold into this segment. So I think the answer can be clear here. There is growing demand. Okay, thank you. Christian?
I think if we look back 15 years ago to JC, there was back then, I think Inyas, you were part of that movement when the first natural fibers. So my perspective is really natural fibers in the sense that fibers growing on the fields and transforming them into composite materials. There was very big excitement around the mammoth. You know, you had built this kind of little hill of natural fibers for the first time, presenting to the composites industry and our ecosystem that, you know, per se it is possible to use to extract the natural fiber and then turn it into a composite material. There was a big excitement around that, but of course there were a lot of things that needed to be fixed in terms of supply chain security and also in terms of functionalization, and we will talk about these things a bit later. So I think this first wave has passed. People have understood that there's still a lot of work to be done. And now I think that companies like ours here have started to have to present the first proof of concept that there are applications we have understood which are where we have a good product market fit, which are the applications which really are we can target with these materials, and also fix some other of the issues. I think now we start really seeing an excitement, and people. Clearly, people are excited about when you come to them and tell them we have a solution to help you decarbonize your supply chain. People are interested, but there is the whole spec list that you need to respect in order to actually enter their supply network. And I think we're just getting there. So I think we're now. The valley of death is behind us, I believe. There has been some consolidation already of who are actually the players who are gonna be shape the market, and we're now really starting to see mass adoption and a market that's being shaped.
Thank you very much for this very enthusiastic and positive statement, Mr. Geyer.
Yeah, thank you very much. Well, we heard that there are many founders and co-founders here sitting with me on the stage. Zatex has been founded 40 years ago, and still we have decided to go into flax, non-cream fabrics. The reason is obvious. It is an interesting development in this market. It is really creating a lot of positive messages, and I would follow my pre-speakers. It has really accelerated over the last years. So there was a development some 5-6 years ago, first rumors, first talking about that. For us, as being an established player in glass, carbon, and aramide, we were considering that as an interesting development, but then we realized that it is really taking up speed, and now it is really going into new applications. We are part of this development. We appreciate this development. We would also like to say that this will have a great future. It is not yet massive quantities, so if you compare it with glass and carbon, it is by tons, very minor, but we believe in it, and we think it will have a great future in many, many applications that will be driven by economical aspects and by sustainability considerations.
Thank you very much again for a positive statement. Now, there are, of course, always challenges, and one of the challenges which we often hear is the supply chain and the availability of material. And I would like to ask Marcus and also Christian to comment on that. How do you feel that this supply chain challenge can be solved, if there is one?
If there is one. Yeah, so one main difference, of course, with synthetic fibers is natural fibers come from plants, and plants grow in certain areas. So, of course, here in Northern Europe, we look a lot into flax. But if you're in Asia, people think in bamboo or in other fibers. So that's very new thinking, that you need to think local, and what grows local, you want to convert into a product. You also don't want to ship it all over the world. So I think the way how the industry works would then be different, and that's of course difficult to adopt. So I think those are things that need to change in the future to really stay local to the source of the plants, the bio-based source. The other thing, what I also see, what we notice if we do analysis of CO2 emissions, is the energy mix per country is also very different. So if you're in France, we're in France here, it's about 50 grams of CO2 is emitted with every kilowatt hour of electricity made. So that's quite low. I come from the Netherlands, and there it's 300, 6 times more. In Germany, it's 8 times more. So if you are located in a certain country, suddenly your CO2 emissions are very different. So the way how you think about supply chain, I think you need to take these points into account.
Okay, thank you. Interesting statements. Christian?
I think on top of what Marcus just said, there is also the requirements of an industry, in the sense that if you look at the natural fiber supply chains, historically they have been very closely correlated to the textile industry. The textile sector is governed by short-lived trends, meaning also that that short-lived trends come with a high level of volatility in terms of pricing, typically of cost. So one thing that we have engaged with, and we have an operations team that has been working on that now for 3 years, is really help educating, and I don't mean that disrespectful at all, but just certifying ourselves for the needs of the automotive sector, and then cascading these needs into the supply chain. So understanding who are the key players who are willing to work with us on that, and then developing really a supply chain that's specifically specifically developed for the needs of the automotive sector. So it means that we talk suddenly about long-term contracts. We talk about 6-7 year long contracts. That of course comes with that's value we can bring to the supply chain in the sense that they're used to having no contracts at all, or maybe 1 year contracts. So we tell them, okay, we come with value in a sense of stability. In return, we will need guarantees in terms of pricing. So these are the sort of discussions that we are having, and then on top of that, really educating the sector, the supply chain about quality requirements, quality management, and how to actually start playing the automotive game. So that alone is, of course, a big chunk of work.
Okay, okay. Thank you very much. And then the question comes also, how can we have a consistent supply of both bio-based matrices and bio-based fibers? And you from the Pond company, you need a basic source materials for your bio-based resins. How do you make sure that your supply is sufficient and will be always there?
Yes, so luckily when we look into what we grow here on the planet, so it is very, very large volumes, and for our bioresins we have chosen to focus a lot on carbohydrates, being one of the most abundant substances here on Earth, so actually exceeding all the quantities that we currently know from the fossil industry, meaning that there is actually enormous amounts of raw material available for creating bioresins out there.
Okay, and for VIA and Materiact, how do you see this as a challenge?
Yeah, what we have done is basically we started more than 10 years ago to tackle that challenge, and we took it a step further than just having, I would say, supplier, buyer-seller relationship. And we formed a joint venture with an agricultural cooperative called Interval to source hemp. And in fact, for them, it was a unique way to diversify the use of their members, the product from their members. And it was a great way of learning how to bring hemp fibers, which was not used at all for technical application, into the market by really integrating, learning together, so teaching really also the end customers, and being able to industrialize and to scale up this product into automotive product. And since then, so we started that 10 years ago. Since then, in fact, you were talking earlier about the development and the prospect. Today, we equip more than 9 million cars with such compounds, with natural fibers. And we foresee that in 2025, more than 15 million cars will have parts with those. You don't see them today. You will see them tomorrow.
Okay, that's a good message. So the message is that basically the availability is kind of guaranteed. You don't have an issue with that.
And the message is we must go beyond the traditional value chain connection, go through partnerships, open innovation, and open the books from the different sectors to be able to unlock this kind of links and connections. Yes.
Okay. Okay, very interesting. A final question on the supply chain and the material itself. The natural fibers and the bio-based resins are by themselves already have a very low environmental impact. But do you see any further ways of reducing the environmental impact of these fibers on one hand and matrices on the other hand? Maybe a question to Marcus and to Christian. A short statement.
Yeah, so you're right. So during growing of the plant, CO2 is absorbed, so you go negative. And what we try to do at Eve Reverse is stay CO2 negative. And that means that all the conversion steps that come afterwards, you need to be very efficient. Every step consumes energy and therefore emits CO2. So what we are trying to do is find alternative routes than the traditional routes in the conversion, and we do that by making it much shorter. So one concept that we're working on is use discrete length of the fiber. The plant grows in a certain length, 40 centimeters. To use that length fiber and create a half product in one step, and then make the product, instead of first making a continuous roving or fiber, make a fabric, and then cut it up in shorter pieces. So that way we make the conversion much more efficient.
Okay, okay, interesting. Christian?
A bit more of a, let's say, an old school or traditional approach, because if you look at the conversion, I mean, it's already very efficient, and it's all only pure mechanical transformation steps, so it doesn't include any step of water or anything. So it's already quite lean compared to what we know from other industries. What we work on is really discussing with our partners, and I agree with what was said before. You know, we talk more and more about partners rather than suppliers. That they actually have control over their energy mix, and that they decarbonize or use as much sustainable, renewable energy sources as possible.
Okay, okay, thank you. So now we have the basic material, the fiber, the resin, and then we start producing products. And then the question to our representative, Mr. Geyer from Sartex, is: do you see any additional processing issues when you replace glass or carbon fibers by natural fibers in your products?
Yes, absolutely. I mean, I would quickly like to come back to Xavier's statement and Christian. That is really the thing, that the traditional way of sourcing, of purchasing materials is not suitable for this kind of applications. You know, I think we have to break borders, you know, to think about partnerships, as you said, and to look for different kind of sourcing. Because it is not this way that you source from a European or Chinese fabrication, but it is really something completely different. Coming back to your question, if you are responsible for a large production facility, you have to cope with the possible challenges introducing a new material. And with natural fibers, it is that we are facing definitely challenges in traditional production of glass and carbon and aramide. That is, for example, the dust and the fuss that is coming out of the natural fibers. And what is even more challenging is the danger of inflammability. So we have to watch this carefully. We have decided to produce our flax NCFs in one of our locations that is smaller. So in case there is a risk of fire, that we have not the big companies getting under risk, but that we are really having this in a local facility that is also protected with sprinklers and all that. So these are the things that we have to consider, and it's not so easy to say you had glass before, now you have carbon, and then you make traditional, natural fibers. It is challenging.
Yeah, and by the way, I think when we changed from glass to carbon fibers, we had a similar challenge with the electrical spark problem.
And still we have. So
and still you have.
If you talk to my technical colleague, he will tell you some funny stories with carbon.
Yeah. Okay. The same question about using bio-based resins. When you make a product out of bio-based resins compared to a product based on fossil fuel resins, is there a difference, or is it simply the same? This is a question both for you from Pont and for Mr. Tyree from Trillium.
Yes. So when we look at incorporating natural fibers into the composite space, so that is a lot driven by the CO2 reduction, and therefore also makes sense to switch from a traditional fossil-based, relatively high CO2 impacting matrix to a bio-based one with a lower CO2 footprint. However, when moving from a glass or a carbon fiber to a natural fiber, there are a lot of things that are actually different, not just in the processing, as just mentioned by Sartex, Christoph, but also in terms of its properties. So the natural fibers, they are a lot more hygroscopic than the traditional fibrous reinforcements. And in addition, there is an anisotropic effect in terms of the coefficient of thermal expansion. And that's probably the reason why this field of natural fibers has started by being used with traditional thermoset resins, where you have a lower processing temperature than with thermoplastic resins, because then this anisotropy in the thermal expansion coefficient is not as important as with the relatively high temperature thermoplastic processing. So one way of overcoming this obstacle would be what is, I would say, currently state of the art in the industry, meaning that you incorporate the natural fibers into a polypropylene matrix where there is hardly any interface between the natural fibers and the matrix materials, meaning that the natural fibers can expand and contract as they wish. However, due to the lack of interface between the matrix and the natural fibers, you're not harvesting the true potential of the natural fibers. So looking into a bio-based resin, which you can develop to have a greater affinity to the natural fibers, this coefficient of thermal expansion suddenly plays a much bigger role, and that is something that needs to be really solved by the industry. So this is not just something you can solve alone by looking at the resin, but it's also something that needs to be done in collaboration with the company doing the structure of the reinforcing fabric. So this is really a joint relation that needs to come into play here.
Yeah. Okay, and that's, I think, something which we will have over and over again, that we need collaboration between the different players, the material producers, the processors, and the end users. Mr. Thierry, what is your experience with bringing a bio-based acrylonitrile into the market, into applications compared to a fossil fuel-based acrylonitrile?
Sure. So what Trillium is trying to do is to make a chemically identical drop-in material. So it is not a new chemical or material. We are not asking downstream partners to change anything, right? And we think that's the beauty of it. We are going to make a bio-based, the carbon atoms from that acrylonitrile are from the biogenic carbon cycle, but we will still be making acrylonitrile. So our ambition is to not require any downstream changes at all.
Okay, okay, very interesting statement. Now that we have kind of solved these problems of processing and having the material, now we have a product. And that product needs to have a certain performance and a certain durability. And my question to each of the people present here is, how do you see the performance of bio-based composites compared to the performance of non-bio-based composites, either fuel-based or fossil fuel-based matrices or bio-based fibers? And the performance, I would like to just give a few keywords. It's about the potential problem of the hydrophilic nature of natural fibers, the problem of bidimensional stability. They have different coefficients of thermal expansion in different directions, fundamentally different from glass and carbon. And we have an issue of aging. But there is also the advantageous issue of amortization of vibrational damping. So there are different performance issues, and I would like to ask to each of you, going from left to right, or for you from right to left, what is your feeling about the actual performance of bio-based composites compared to non-bio-based composites? Christian, to start with you.
Yeah. So again, I think as we are trained to, and we like to as engineers and as composite engineers, we very much focus on the hardcore engineering metrics based on mechanical properties, right? So we think in terms of performance per weight ratio. So there are some key facts and figures that when you look at flax or hemp-based composites, we have a lower density than the synthetic-based composites. However, you also have especially lower strength, equivalent, similar stiffness than glass. So once you have kind of figured out the metrics you have there intrinsically with the fibers, and you have developed your architecture of the fabric based on it, then you can then go and understand where you have your ideal product market fit, as I mentioned before. So that alone has been a work, I think, that has taken us probably 4 or 5 years at Bcom to really understanding which are the markets we are targeted. And I think that also answers the initial question, and we had we discussed this briefly before. Is natural fiber composites going to replace everything else? Of course, no. Carbon has unique properties that are out of this world. I personally wouldn't really like sitting on an airplane made from a fuselage from flax fiber composites, right? So you have to understand where are the sectors at the beginning there are niches. They might be niches which you can go and target. And then once you have figured it out, and we started with the sports and leisure industry, we then identified the motorsport sector as our entry door into the large-scale mobility sector. Then you start understanding the specific requirements of each of these markets, right? So just to name an example, once you go and talk to the people in interior automotive, they will start talking about long-term properties, so accelerated aging, quite nasty tests they will expose the material to. As soon as you get into visual surfaces, of course, there's all these these aspects of how to design with the materials, what is a natural imperfection that is a feature of the material, and what is something that is out of spec because the designers and the car makers won't accept it. So I think those are then, and then of course you have UV resistance and scratch resistance. So once you have understood your market and what you target, you start with this whole catalog of specific requirements which you really need to by iterative process, and once again, you're not going to solve it by your own, so you need to partner, you need to create this network of people to solve the problem. And that is, again, a process that takes quite a long time.
Okay. Very interesting. Mr. Taghi, your situation is completely different in the sense that you make a precursor for a precursor of carbon fiber. So do you have already data or insight in how the change of acrylonitrile to bio-based might affect the properties of the carbon fiber? Because that is, I think, a question which many of the audience might have.
Yeah, and people may get tired of me saying this, but we're not changing from acrylonitrile to bio-based. We're changing from acrylonitrile to bio-based acrylonitrile, right? So still the same chemical, been around for 50 plus years. And so the carbon fiber, look, we do not make carbon fiber. We have no intention of being in that business, right? We just make this material. And the material that has been made by the experts, carbon fiber from our material, exhibits performance equivalency with the same made from the gray product.
Okay, so that's good news and comforting news. What is your feeling about the performance of the bio-based non-chem fabrics you're producing compared to glass and carbon?
Well, I think it is important to define performance beforehand, because I would see it as unfair to compare the mechanical performance of a natural fiber to the mechanical performance of carbon or glass. So I would say the performance of a natural fiber and natural NCFs and materials made from natural products are completely different in environmentally friendliness, in sustainability, in CO2 emissions, all that. So if you see that, I would say you cannot compare apples with pears, and you cannot compare natural fibers just simply with glass or carbon. Different applications, as you said, you don't want to sit in a plane where no carbon is used, but it is natural fiber. So from that point of view, I think it is a great product, it's a great new development. And one story that I would like to tell, some 35 years ago, when Zatex, it was largely before my time, when Zatex was developing these glass applications, there was a statement of one of the famous OEM makers in wind turbines that is still on the market, that the maximum length of a wind blade will be 6 meters. 6 meters. Today we are just facing here the first 136 meter long wind blade made from glass fiber. So also that was a development. So where the performance of glass and carbon is today, that was not right from the year of birth of these products, but it developed technically step by step.
Okay, so you don't see any major hurdles in using the natural fibers in certain applications, not in all applications, but in certain applications.
That's it. I think it will be applications that are suitable for natural fibers. There will be applications that may not, medium short term, be suitable for natural fibers, but there will still be a technical development in natural fibers that will take us to new horizons that we don't expect today.
Okay. For the bio-based thermoplastics, are there any performance issues, or do you see even better performances than with fossil fuel-based thermoplastics?
Yeah, I think I'd actually just like to build on what Christoph just said. So it is an evolving industry. So what is known today is mainly a PP thermoplastics used to bond the natural fibers. And due to the lack of interface, you don't really harvest the true power, the true strength of the natural fibers. But we can see that when substituting PP with our bioresin, we see an improvement in the mechanical properties. So it simply gets stiffer, it gets stronger. So that is one approach to take the natural fibers one step further.
And did you deliberately change something in the chemistry and the molecular structure of your thermoplastic, of your PP, or is it just by coincidence that it happened?
So I'd say, so what we have is not really PP, but it is a bio-based resin, so belonging to the polyester family, and we specifically designed this resin towards binding to natural fibers, so you know
so
that...
it's a PLA type resin?
Yes, it's a PLA type, but with strong, or you could say modified PLA resin with the affinity to bond covalently to natural fibers, really giving the strong interface and therefore seeing a large improvement in the mechanical properties of the final composite part compared to the traditional inert thermoplastic polymers. And if we look at the natural fibers, so that is, you could say, a potential, and there are also drawbacks. So you can say, one example was just that probably shouldn't make a fuselage out of natural fibers. I would say not only just from a strength perspective, but also due to the fact that natural fibers, they are so finite in length, so they simply come from nature hands in a given length, and although you can spin them into a continuous yarn, you still have weak interactions between the individual fibers, meaning that when you go to larger composite structures, for instance, such as a wind turbine blade, that starts to come into play and limit the application. So when talking natural fibers, so I definitely believe that there is room for improvement based on the current state of the art today, but there are also, as already described, some areas where natural fibers are not suitable.
Yeah. Although I would say that if we see here, certainly in France, the application of flex fibers in big boats and catamarans and trimarans, these are heavily loaded structures, and still they go on the ocean in the big waves, and they survive. So there is a potential also for making high performance applications with natural fibers, I think. Marcus, what's your opinion on durability of bio-based composites? Or other aspects in the performance?
It's a very broad question. So when we look to polymers, we see polymers that are a drop-in. So for example, what we find interesting is bio-based high-density polyethylene, because it's what we see one of the very few polymers that's actually CO2 negative, and it's exactly the same polymer. So you can just use it as normal PE. There are also polymers, like your polymer, but there are others that have other characteristics. There are, for example, also the furine resins that are very fire resistant. So you can exploit that benefit. So it really depends how you want to use it. And there's maybe one other consideration. There are many engineers here, so all of us know the term specific density of a specific stiffness. So you divide the stiffness by the density, and natural fibers are lighter. But I think it's also important to think about CO2 emissions. So you get a certain stiffness, let's say, and there's a CO2 emission of the polymer. And then what's the best choice? And then you will see different results. Because, for example, epoxy is very stiff, but also has a quite high emission. So other polymers then become more interesting. So it's also thinking in other metrics and then finding the optimum.
Okay. So you are at Forvia mainly in injection molding, mixtures of thermoplastics with hemp fibers. If you compare the performance of these products with alternative products, what's your feeling? Are you in the right track, or do you need further improvements?
we can always improve. But I think the mindset of this discussion is around, okay, there is bio-based materials like bio-based polymers, bio-based building blocks like acrylonitrile, and indeed the intent is to go as a drop-in. So whatever molecule being bio-based or not, in the end is the same molecule. Now when we talk about natural fibers, it's usually to replace other type of fibers for weight reduction, for carbon emission. And the way we have tackled this issue is not thinking of I need to replace, I need to have the same specs. We take the material for what it is with its properties, and we have the ability to understand the material science, so what material does. We have the ability to combine it with the process, so injection molding, compression molding, other types of transformation processes. And we have the ability to combine, to do the synergy with the architecture, with the design of the part. And having all those capabilities, we in fact can design the part or to fit the material as well. And therefore, we have, if I come back to the example I was giving on hemp fiber-based compounds, we could replace PP with glass fibers, bringing 20% weight reduction. But that's not the same part.
Yeah.
That's just a different construction, a different way of placing ribs, reinforcement, opening, and so on. And we make a material and a fit for an architecture, and the architecture fit for process and the material. And this way, I think we can, it opens up solutions, not just a very transactional development as we may have been doing for a number of years. And that gives, if I can give an extension to that, so as I was saying, we have developed those materials for structural parts, and now back to Christian's comment, it helps us to learn then how we bring it to the surface to meet durability, odor, UV appearance requirements, but again, designing the right, being able to educate on the type of grains we want to have, to do certain aspects with the right fibers, etc. So it's really trying to combine the different aspects of the value chain to have the right materials for the right design.
So, in summarizing all this, and by the way, I should tell you that after this session, in 15 minutes, all the speakers here will be available for a half an hour, somewhere there. If you want to ask personal questions to them for further clarification, or if you disagree with certain of the statements, you can find each of us at 1 o'clock just outside the Agora. If we summarize all this, my impression is that we have, in fact, to not really to rethink, but to adapt our designs, to adapt our processes to the fact that we are using bio-based fibers and bio-based resins, but not in a fundamental way. We still can use basically the same production processes, the same design rules, but in order to have the optimum performance, we might have to adapt certain aspects of the process, certain aspects of the design. May I ask to each of you to make a short statement on whether you agree with this, and if not, what, in your opinion, could further be improved to open up more applications for bio-based composites in the real world of composite applications. So I don't know who wants to start with a statement.
Yeah, I can start with a statement. Yeah, thank you. So yeah, now we've covered a bit some of the advantages and disadvantages of natural fibers, and that has led us at Pond to consider what can be done in order to take bio-based composites to the next level. And one of the things that we have come up with is what I will be presenting now. So for the first time, so that is a self-reinforced, so fully bio-based composite, meaning that the reinforcing fibers and the matrix are made from the same material. And I just brought a small poster here. We also have samples afterwards you can come and see for the 1 o'clock event, the Q&A session. So where we simply substitute the natural fibers with our fully bio-based but synthetic material, meaning that we can make the fiber continuously long. And because it is one monomaterial, it means that we have perfect interface between the materials, and we avoid some of the drawbacks from the natural fibers, such as the high water uptake and the very unusual thermal expansion coefficient of the fibers. So we also see that this can further reduce the density. So we already see a density reduction going from a glass fiber to natural fiber. This then leads to a further density reduction, meanwhile having a positive impact on the mechanical performance due to the very good compatibility. So we consider this one of the approaches to bring fully bio-based composite into, you can say, version 2.0.
Okay, thank you. Interesting development. Do we have from other partners here?
Regarding the adoption of these new materials, what we also foresee is a need for transparency and traceability. And I think in that respect, the value chain has quite a lot of work to do to be able to bring that to the customers in the industry, but also to the end users. And it's even, I would say, it's even more challenging when we talk about natural resources. Because again, we go beyond the traditional way of thinking of we manufacture something from the oil, etc. Now it's about, okay, where have you grown these natural fibers? Is it a sustainable practice? How do you do it, etc.? Are the farmers properly incentivized, etc.? Does it compete with other resources? And we see that as probably the main next step through regulation, but also through industry practices to unlock the adoption of those solutions.
Yeah. In that respect, I think I can mention to the audience that for flax fibers at least, what is now called the Alliance, so the European Flax and Hemp Association, former name CLC, has now produced a full life cycle analysis of flax fiber rovings, which can then be used as an input for LCA analysis of flax fiber-based composite products. And I think we will have, and we will need more and more of these transparent data sets on the ecological impact of not only fossil fuel, but also bio-based fibers and matrices. Marcus, do you have a feeling on what could be further developments?
I have two comments. One is in the LCAs in Europe, the CO2 uptake by the plant is not always taken into account. And to me, it doesn't make sense, because that's one of the reasons why we try to use bio-based materials. So I think in the way how LCAs are calculated could be improved by taking this uptake into account. I think that's one important one. And the other is, but maybe it's not a popular viewpoint, CO2 tax. We're doing everything as companies, as engineers, to make bio-based materials available. But let's say the benefit for society, less CO2 emission, is not priced. So I think that's more for the governments to do, to really make that playing field more level by taxing CO2 emissions better.
That's an interesting statement, and I don't know whether the other people also have some statements on how the government or the bodies which control our life, big companies and so on, but also the government can further help us in making these bio-based composites acceptable and making them breaking through into the market. Do you see a role for governments and for big end users? Christian?
I think, so first I would just like to elaborate on two comments you made before, which I think are very important. Christoph said before, first we need to define what is performance. And you, Inyas, you made in the statement, be aware there are high performance applications out there featuring natural fiber composites. And I think that's very important. When I say that, we shouldn't be using natural fibers for a fuselage of an airplane, if you look at the fuselage, it's merely designed for strength, right? And that's not the sweet spot of the natural fibers, not most of them at least. When now you talk about applications that are designed for stiffness, it's another story. And when you see typically one target that we have and that we have entered successfully is body panels for race and supercars, where we have demonstrated that we can develop a material that has the same bending stiffness per weight ratio as the equivalent carbon part. So we replace carbon fiber composites at ISO performance, plus we eliminate a safety problem, which is the debris of the carbon debris on the racetrack, which can puncture tires. So just to be clear, there has been, and I think there still is with some people, this general misconception that you trade, you basically get rid of the synthetic-based composites, and then you lose benefit in terms of performance, and then you have a greener story, and you're okay to decrease the performance. I don't think anyone here, is trying to sell you that story. So first, it's in our responsibility to come with products that outperform whatever we replace based on pure engineering metrics, full stop. And then there is a whole sustainability story, and that feeds into the next discussion. What I would like to see is that when people like us come with products that present these benefits on pure engineering metrics, then I would like to see clearly governments and authorities and the legal framework to actually pull those into the market, right?
Yeah.
And then, of course, you can start talking about social cost of carbon and how is it possible with the very aggressive targets that we have that some quite nasty materials are not more penalized in terms of cost, in terms of taxes on the market.
Yeah.
Of course, we cannot compete. If you look at some of the supply chains out there which have been there for 20, 30, 40 years, we are now just at the verve, at the beginning of building that supply chain. We are not at the efficiency levels of established materials. So there I would expect the legal framework to support us and help give us the tools to actually pull these solutions that are, we have proof of concept, we know we can deliver on performance, then there should be an accelerator that actually helps us switching to circular economy.
Yeah. From Sartex, do you have a similar feeling?
Well, I was listening carefully, and I think it is, if governments or institutional bodies impose something, it is difficult to get the acceptance from the market. I prefer to have this bottom-up approach, that there is more coming by a change of the mindsetting. I think there are much more possible applications for natural fibers or alternatively produced carbon precursors if the mindsetting is changing. So it's on us at the end. It's on us to decide for going a different way, using a different path to success and opening the chance for an alternative fiber. I think that is more coming bottom up instead of asking they have to support. I agree with Christian, that is very important. If there is a product suggested, that it should be supported by the governmental bodies, but imposing rules and regulations, I think, is not the right fertilizer for using these products.
Yeah. Yeah. On the other hand, one could say that if the governments are imposing kind of rules for which products they buy themselves. The procurement possibilities that they say, okay, whatever we buy as a government, it should have a maximum ecological impact, and then indirectly you will favor the use of bio-based composites. I think also, before coming finally to you, I think also that we need to show the nice applications of bio-based composites. I think the CLC, the Alliance for Flax and Hemp Fibers, has done over the past years here in the JEC a tremendously good job in showing all kinds of applications of bio-based composites. And that, I think, opened the eyes of many people that indeed a lot of things are possible. I would like to come finally to you to ask a question. Almost all of you, or at least 4 out of the 6, have been founding their own company in these bio-based composites. How important it was that you were kind of supported by a community of either composites related and composites enthusiastic people, or by bankers or capital providers who support your ideas, and who support your ideas, which are in a way quite difficult to achieve because the material is very novel. So you told me that you were supported by a Belgian venture capital company from America. So how do you play that game, briefly?
Okay, so maybe that's a bit of a curveball, but I'm going to swing. So Trillium was formed during the pandemic, the very start of the pandemic. And I would say, like a lot of pandemic companies, what happened is that the location in which you were at becomes not that important. I think the benefit and advantage to any location has been neutralized in this world that we're living in. And you see this. Trillium, what we are doing would not have been possible 10 years ago. I have employees in 6 states, capital from South Korea, Germany, Belgium, and the United States. So it's global capital. I happen to be in Tennessee. I work out of my home office. We have a pilot plant in another state. We're building a demonstration plant on the U.S. Gulf Coast. I mean, we have partners in at least 10 states. And so I think the way we are operating has completely changed, but I don't think it's unique now. I think there's many companies doing it just this way. And why? You can get the best people that way. It's all about people. The money can come from many places, but you must be open. If you open the talent pool up to not just your city, but to the world, you get great people.
Okay, very nice statement. I would like to finish up. We have 3 minutes to go. We have 6 people. So if each of you could give in 30 seconds, what is your vision for the future of bio-based composites? And let's start from my right side in 30 seconds.
So, well, the vision or the perspective for the next years is certainly positive. We foresee and we see a lot of traction from the market on those materials. As I was saying, we don't necessarily have a magic stick to convert everything from one day to the other. So we have some expertise, and I would encourage you to come and see us on the Q108 near Agora 6, and we'll be happy to talk about your specific use cases.
Okay, thank you. Marcus?
Yeah, my view is that there will be a lot of growth because I think it's just very much needed by society. But I also think there will be more specific technologies developed for bio-based materials, not just using the conventional ways with the different materials input, but really think about new ways of processing them, of new ways of designing the parts. So I think that will all be changed in the next years.
Okay, thank you.
Yeah, so I think also it will grow in the future, but things takes time, so we need to be patient. Things need to mature, and supply chains come into place. And if we look into the past, where it's been, say, 2 or 3 types of reinforcing fibers and 2 and 3 types of thermosetting matrices, I think it will be much more diverse in the future, combining natural fibers, for instance, bio-based carbon fibers, as with Trillium, or bio-based polymer fibers as we present with various matrices. So I think we are going to see a much broader bio-based composite landscape in the future compared to what we've been used to.
Okay, thank you. Interesting.
Yeah,
Mr.
just
Geyer.
follow what my pre-speaker said. I think there's a great development in front of us. Natural fibers and products made from natural fibers have left the niche It was a product some years ago where people smiled about and didn't see the performance and all that. So it has left the niche. If we see all the companies here, I think it will continue to grow and will have a very meaningful position in this composite market in the future.
Thank you. Mr. Taigi?
Yeah, so the takeaway I'll leave you with is that upstream innovation's absolutely happening. I think it really began maybe 10, 15 years ago, but now it's accelerating. Now we're at the point where you're starting to see some things leave the early low readiness level stage and mature. So if you'd like to learn more, check out our progress at the Sciensco booth. Our progress is on display there. Thank you.
Thank you. And finally, Christian.
I think we have a beautiful cross-section of what future circular economy means here on stage. You know, from people using natural fibers, feeling on the fields as actually a raw material input, all the way to people using, you know, just basically taking the carbon atoms from somewhere else, right? From a bio-based. So I think that is a very good cross-section of what is happening and what will happen. For us, it's very important to push this mass adoption. And you know, we're spreading now into the large-scale automotive industry. We have projects also for passenger aircraft and other mass transportation. And I think that's what the industry should be aiming at, and really further developing solutions and proving that it is a new product, a new solution for the mass markets out there.
Okay, so I would like to thank, with all these very positive statements, really believing in a big future for bio-based composites, bio-based matrices, bio-based fibers. With this, I would like to close up and finish this discussion. You can ask many questions, as many as you like, when all 7 of us will be present there outside the Agora for answering your questions, concerns, suggestions, maybe. So I would like to thank all of the 6 presenters here for interesting statements, and I wish you a very interesting show further for the upcoming days. Thank you very much.